9.4 is called implicit differentiation. So what is an implicit differentiation? First thing first, let's look at the difference between explicit and implicit. For explicit, we have y equal to 3x squared plus ln x, and say that we want to differentiate this with respect to x. So we will differentiate each term. So we can write it like this. D over dx y is just dy over dx. Here we have d over dx 3x squared. So this means that we need to differentiate 3x squared with respect to x, which can be done since we have x here and we need to differentiate with respect to x. Since they are the same unknown, which is x, you can differentiate 3x squared and the answer is just 6x. And the last one is to differentiate ln x with respect to x. Since this is x and this is also x, this means that we can differentiate ln x. And the answer is 1 over x. So our aim when we differentiate is to find dy over dx, which is this one. So straightforward, when you can find the answer like this is explicit. So what's the difference between explicit with implicit? Say that you have y squared equal to 3x squared plus ln y, and we want to differentiate this function in order to find dy over dx. So we will differentiate each term. On the left hand side, we have d over dx y squared. So we need to differentiate y squared with respect to x. So we can see that here we have y squared, but here is x. They are not the same unknown, and this will not give you dy over dx since now we have y squared. If it is like this, straightforward, you will get dy over dx since this is just y to the power of 1. But now we have y to the power of 2. And this is what we call as implicit differentiation. So we need to apply implicit differentiation for the first term here, and you will need to find what is the answer. We need to differentiate 3x squared with respect to x. Since this is x, this is also x, you can just differentiate it as per usual, and the answer is just 6x. Now, what about the last term here? We need to differentiate ln y with respect to x. So here we have y, but here we have x. So they are not the same unknown. And here we have ln y. Since it is not y to the power of 1, this will not give you dy over dx. Instead, this is actually an implicit differentiation. And then find the answer. And from this part here, you will need to rearrange in order to find dy over dx. Let's do example 14. Question 1, differentiate the following with respect to x. So for question A, we have d dx 3y cubed. So this means that you need to differentiate 3y cubed with respect to x. This is y and this is x. So they are not the same unknown. And since this is not y only, we have 3y cubed. This is an implicit differentiation. So I'll be teaching you two methods. The first method is the longer method by using chain rule. So what we're gonna do is that we're gonna consider this to become m. So let m equal to 3y cubed. And hence, this will become dm over dx. So we will apply chain rule here. So you're gonna have dm over something times something over dx. So this is dm and this is dx. So we need to find what should we put in these two spaces here. So let's look at your m, which is 3y cubed. So if you differentiate m, since this is y, when you differentiate m, you'll get dm over dy, because m is in terms of y. That's why we get dm over dy. So just differentiate 3y cubed. Just imagine like you have 3x cubed. So how do you differentiate 3x cubed? You bring power to the front. So you'll get 3 times 3. And then you just copy down x. In this case, we're just going to copy down y. What happens to the power? It is 3 minus 1, which is 2. And hence the answer is 9y squared. Since this is dm over dy, therefore this one should also be dm over dy. And if this is dy, this is also dy. So why should we have dy here and here? This is because when we cancel out dy, that will give you just dm over dx. So that's why these two should be the same. So let's substitute. We know that dm over dy is 9y squared. And here is dy dx. So just put down dy over dx. And hence, this is actually 9y squared dy over dx. So that is by using method 1, chain rule. There's actually a shorter method. We want to differentiate 3y cubed with respect to x. Since this is y, but here is x, we know that this is implicit. So what you're gonna do is that, just straightforward differentiate 3y cubed. Just imagine this is x. So if you differentiate 3x cubed, you'll get 9x squared. And hence, if you differentiate 3y cubed, you'll get 9y squared. And for implicit differentiation, you only need to put dy over dx at the back here. So this is the shorter method of applying implicit differentiation. And in my opinion, it is better for you to use this method too, because it is much easier and shorter.